magnetic particles. You can see the experimental setup for the discovery of an electron. It shows a cathode ray discharge tube. A basic rule regarding the behavior of charged particles is like charges repel each other and unlike charges attract each other. In the mid-1850s, many scientists, mainly Faraday, began to study electrical discharge in partially evacuated tubes, known as the cathode ray discharge tubes. The electrical discharge through the gases could be observed only at very low pressures and at very high voltages. When sufficiently high voltage is applied across the electrodes, current starts flowing through a stream of particles, moving in the tube from the negative electrode, that is the cathode, to the positive electrode, that is anode. These were called cathode rays or cathode ray particles. The flow of current from cathode to anode was further checked by making a hole in the anode and coating the tube behind the anode with phosphorescent material zinc sulfide. When these rays, after passing through the anode, strike the zinc sulfide coating, a bright spot on the coating is developed. The results of these experiments are summarized below. Number 1. The cathode rays start from the cathode and move towards the anode. Number 2. These rays themselves are not visible, but their behavior can be observed with the help of certain kind of materials, as fluorescent or phosphorescent materials. These materials glow when they are hit by the cathode rays. Television picture tubes are cathode ray tubes, and television pictures result due to the fluorescence on the television screen coated with certain fluorescent or phosphorescent materials. Number 3. In the absence of electrical or magnetic fields, these rays travel in straight lines. Number 4. In the presence of electrical or magnetic fields, the behavior of cathode rays are similar to that expected from negatively charged particles, suggesting that the cathode rays consist of negatively charged particles called electrons. Number 5. The characteristics of cathode rays do not depend upon the material of electrodes and the nature of the gas present in the cathode ray tube. Thus, we can conclude that electrons are the basic constituent of all the atoms. Here you can see a cathode ray discharge tube with a perforated anode as shown. Here you can see the experimental setup of J.J. Thomson to calculate the charge to mass ratio of electron. Here the deflection is seen towards the positive plate. Therefore, it was concluded that electron is negatively charged. As negatively charged particles are attracted by the positively charged particles, hence the cathode rays are made up of negative charges, which are called electrons. Moreover, Thomson argued that the amount of deviation of the particles from their path in the presence of electrical or magnetic field depends upon number 1. The magnitude of the negative charge on the particle. Greater the magnitude of the charge on the particle, greater is the interaction with the electric or magnetic field and thus greater is the deflection. Number 2. The mass of the particle. Lighter the particle, greater is the deflection. Number 3. The strength of the electrical or magnetic field. The deflection of the electrons from its original path increases with the increase in the voltage across the electrodes or the strength of the magnetic field. Thomson was able to determine the value of E by ME as E by ME is equal to 1.758820 into 10 to the power 11 coulomb per kg, where Me is the mass of the electron in kg and E is the magnitude of the charge on the electron in coulombs. Since electrons are negatively charged, the charge on the electron is minus E. Here you can see the setup of Millikan's oil drop experiment, which was used to find the charge on the electron. Click on the play button to start the atomizer. In 1913, the American physicist R. A. Millikan performed the pioneering oil drop experiment for the precise measurement of the charge on an electron. He found that the charge on an oil droplet was always an integral multiple of an elementary charge, that is 1.602 into 10 to the power minus 19 coulombs. Millikan's experiment established that electric charge is quantized. From the values of charge and specific charge, the mass of the electron could be determined. The animation takes you through a journey of discovery of proton. Here, the preview shows a glimpse of what lies inside an atom. This is the nuclear model of an atom, where the central position is occupied by a nucleus. Proton is the fundamental particle of an atom. In 1886, E. Goldstein discovered rays that were flowing from anode towards the cathode. Such rays were called canal rays because they pass through the holes or canals present in perforated cathode. The anode rays or the canal rays or the positive rays are made up of positive particles which are called protons. This shows the animation of the phenomena which took place during the discovery of neutrons.